Okay, in Algebra 2, you were asked to solve equations in this form. Ax squared plus bx plus c equals 0. Remember, yes?
Oh, I remember.
Okay. Now, here's another question for you. What does that graph as? Raise, please. Sydney?
No, I don't remember.
What is that graph as? We've done them this year too. Parabola, very good. So this graph is a parabola. Okay. What are we finding? When we solve for x? So I think everybody has an idea of what a parabola looks like. Well, what does that mean when you take the equation, you set it equal to 0, and you solve for x? And remember, we're solving for not just x, but we're solving for x squared. So that means we get two things in relation to the parabola. Raise, please, don't blur. We get two things in relation to the parabola. Go ahead. Yes. Okay. So a parabola has a vertex, right? That's either the low point or the high point. And then the parabola has x-intercepts. So you are exactly right, Philip. What we are finding is we're finding x-intercepts. And I know I still haven't answered the question, why do we need complex numbers? But hang on to your seats, it's coming soon, okay? There's 3 cases for the graph of a parabola for finding x-intercepts, okay? Letter A. Draw yourself a little coordinate plane. That was very good, Philip. It took block A a little longer to get that, okay? And let's say that the vertex of the parabola was here. And let's say it opened like so. Okay? Gang, how many x-intercepts do you guys see? 2. They're right here and right here. So when you're solving a quadratic, after you set it equal to 0, what you're doing is you're finding the x-intercepts. In this case, there's 2 real x-intercepts. Everybody good? All right, case B. New parabola. This time, vertex is there. How many x-intercepts, gang? Okay. 1 real x-in. Okay. Have we answered the question why we need complex numbers yet? No. Letter C. Anybody know what I'm going to draw for letter C? Raise, please. No x-intercepts?
Yeah.
Okay. So let's say vertex here. Okay. So no real x-intercepts, correct? But you will still get 2 answers. And they will both be imaginary. Okay? So do we see any x-intercepts? No. But could we still solve the equation for x? Yes. But what kind of answers are we going to get? We're going to get what's called complex numbers, okay? Or imaginary solutions. There are no x-intercepts, but we will still get solutions. That is why we need complex numbers, okay? It's for this case. It's for parabolas that never intersect the x-axis at all. So why do we need complex numbers? That's why. Otherwise, we wouldn't be able to solve the quadratic equation for the x-intercepts. Okay, so far? I'm going to give you guys a little hierarchy of complex numbers. Every number that you've ever known is a complex number. Okay? Complex numbers are written in the form A plus BI. Does that sound familiar at all?
No.
From Algebra 2? No? Okay. Okay, A is called the real part. BI is called the imaginary part. If we didn't have complex numbers, we couldn't solve this equation. Okay, so that's why we have to have complex numbers. Okay, in the hierarchy of complex numbers, off of complex numbers are real numbers. Now, those are all the numbers that you guys have studied in your educational career. Okay, real numbers can be written in complex form. It looks like this: A plus 0i. Okay? A plus 0i. So throw any number at me.
26.
26 can be written as 26 plus 0i. And you have taken 26 and written it in complex form. There's no imaginary part, there's just a real part. Does that make sense, guys, so far? Okay. All right. Off the other side of complex numbers is imaginary numbers. Those are the kind of numbers you're going to get as solutions for this kind of parabola. Okay? Imaginary numbers are in this form: 0 plus BI, where there's no real part, but there's just an imaginary part. Okay? All right, let's talk about the imaginary stuff. The square root of -1 is called I. So, it used to be very bad when we got a negative under a square root, okay? Now in this unit, we can deal with a negative under a square root. Previously, you couldn't. I didn't want you to get negatives under the square root or something was wrong, okay? So, I'm going to show you how to write a complex number using the letter I. So example 1, letter A. We're going to take the square root of -9 and we're going to write it eventually in complex form. So the first thing we're going to do is break up the square root into 2 separate square roots. One of them is -1, the other one is 9. Now, can we multiply things under roots? Yes. So -1 times 9 is -9. Everybody agree? Okay. But the square root of -1 is the letter I. And the square root of 9, gang, is 3. So now, could somebody tell us how to write that in complex form? So it has to end up in this form, A plus BI. So anybody know how we could write that in complex form? Sydney? No, there's no plus in between here, so be,
Zero.
so now what do you want for the real part?
0 plus 3 I.
0 plus 3i's. I's always go at the end, guys. So
Just write as 3.
preferably not. Most of our answers, they do want in complex form. Okay, so 0 plus 3i. Okay, so really, all you're doing is when you see a negative square root, under a square root, you go ahead and write out, you pull out an I. Negative under a square root, pull out an I. Pull out an I. After today, I'm not going to make you write this. All you're going to do is you're going to pull out an I. But for the next example, we're going to write it with the negative root 1. So square root, negative 24 can be written as 2 square roots. Negative 1 times 24. Everybody good? Okay. Sam, what is the square root of negative 1? It is I. It's you? Is it you, Sam? Or is it I? Now I'm messing with you. It's I. Okay? Square root of 24. We're never going to leave square root of 24, and you better not have that on your test either, because this breaks down. Somebody got the numbers for me raised, please? Somebody got, Molly, what do you got?
6 and 4.
Yeah, do you want 4 first or 6 first?
4.
4 and 6? Sounds good, Molly. Okay. And Nick, the square root of 4 is? So times 2 times square root of 6. Now, how do we rewrite that in complex form? Right? Do we have a real part, gang? Anything that we can add plus bi? Any real number sitting by itself here? No. So it's 0 plus, okay? And I always goes at the end, guys. So once you have an I, you put I at the end. And then the 2 root 6. So that would be the correct form. It's on the test. Yes, they are on the test, okay? So we're going to write A equals, B equals, C equals. Okay, Trenton, pull the numbers out. A is the number in front of x squared. B is the number in front of x. Good. And C is the constant. There you go. So please, guys, before you do the solving, actually do that, set that up. Okay? All right, off we go. Don't start punching yet. It's not time. X equals the opposite of negative 4, which is 4, plus or minus the square root of negative 4 squared minus 4 times A, which is 1, times C, which is 5, all over 2 times A. Don't punch yet, guys, or you're going to get the wrong answer. So 4 plus or minus. Now here's what I do on the inside. I do negative 4 squared is 16. And then, trust me, this always works. Do this as negative times a positive times a positive. So a negative times a positive is what, gang? Yeah. Negative. And now just do 4 times 1 times 5, which is 20. All over 2. Don't punch anything on your calculator. 4 plus or minus square root of, gang, 16 minus 20. Negative 4 all over 2. Everybody good?
It's a negative 4. On top. Or the B value in front of everything.
No, it's the opposite of negative
it's
4.
the B,
Okay? All right, then we're almost to the end. Whenever you have a negative under a square root, remember, pull out an I out of your noggin. Out of your noggin, pull out an I. Pull out an I. The letter, of course, not the real I. Okay? So we have I, and then square root of 4, gang, is 2 all over 2. So that's 4 plus or minus 2i all over 2. There's one last thing to do.